The question says propanal and pentane 3-on are the ozonolysis products of an alkene. Okay, alkene undergoes ozonolysis reaction to produce propanal and pentane 3-on. What is the structural formula of alkene? Okay, we can write this chemical reaction. We have reactant alkene is there. We can mention alkene. Here we have alkene is there. Alkene in the sense it is having double bond. Okay, undergoes ozonolysis. Zn it is H2O is there and products propanal. Chemical formula we can write CH3 CH2 and CHO is there, aldehyde having 3 carbon. And next pentane 3 on means it is ketone. You can see on is there, so we can mention this is how many carbon, pentane. So C C C C and C, 5 carbon. To the third carbon we have double bond O. Okay, keto group is the CH3. We can satisfy valency of carbon CH2 and it is CH2, it is CH3 is there. Okay, these are the products we have. These are the products we have. Okay, with the help of the product we have to determine the chemical formula of the reactant, and then okay, only structure formula we have to determine. We don't need to write the IUPAC name. Okay, now pay attention carefully in this case how we complete these kind of reactions. I give one example. Let's say I have a reaction. Let's say we have CH3, it is CH double bond, it is CH2 is there, alkene, and it undergoes ozonolysis O3 and it is Zn. We can mention it is Zn and it is H2 is there. To form the product, what do we do? Wherever the double bond is there, so we break the double bond. Let's say I am breaking this double bond. Both the bonds are broken, and both side where we are breaking the double bond, both side we attach oxygen to satisfy the valency of carbon. Keep in mind this is oxidation reaction. Addition of oxygen is also oxidation reaction. This is what we got. One product is there. We have one product. This is one product we got because these two bonds are broken. This is another product is there. Okay, let me write this product. We got CH3, it is CH double bond O, and plus another product we got CH2 and double bond O is there. These products are there. For a while, let's say I have no any idea about the reactant. We have only product. Okay, like this question. We have only product, and from the product how we can identify the reactant. So you have to focus on the oxygen. Where the oxygen, you can see here we have the oxygen. This is the oxygen, this is oxygen. Okay, so remove these two oxygen. Okay, you remove these two oxygen and see to which carbon these oxygen are attached. You can see this oxygen attached to this carbon, and in this case this oxygen attached to this carbon. Okay, now to satisfy the valency of these two carbon, we connect these two carbons via double bond. That's it. After removing oxygen, okay, both the oxygens are removed, and you can see the carbon to which oxygen are attached. These carbons are attached via double bond to satisfy their valency. Okay, now we have CH3 CH and double bond CH2. We got CH3 and it is CH double bond, it is CH2 is there. Okay, this is the chemical formula of the reactant. You can see same CH3 CH and double bond, it is CH2 is there. That is how we can determine the chemical formula of the reactant. Same method we are going to follow here also. Okay, so let's say we have the reaction. Reaction is alkene. Okay, so alkene I assume it is A reactant. Reactant A is there, A, and it is undergoing ozonolysis O3 and it is Zn and it is H2 is there. Okay, what is the product? Propanal CH3, it is CH2 and then CH double bond O is there, and plus pentane 3 on is there. So we have CH3 CH2 and C double bond, it is CH2, and we got CH3 is there. These are the products. So focus on the oxygen. Okay, you can see oxygen is present here. This is oxygen, this is also oxygen is there. This is oxygen. So we cancel these oxygen. Let me change the color. We have oxygen. We cancel these two oxygen, and now focus where these oxygen are attached to which carbon. This oxygen attached to this carbon and this oxygen attached to this carbon. Okay, so we connect the carbon with the double bond. Which carbon? To the carbon to which oxygen are attached. These carbons are connected via double bond to satisfy their valency, like this. Okay, to satisfy their valency. So this is the longest carbon we have, so first of all I write this one. We have CH3 and CH2 and then C, and then to this C, CH2 CH3 we can complete other side chain also, CH2, and this is CH3 is there, but this carbon is connected to CH. Okay, we have double bond CH and then we have CH2 and it is CH3 is there. Okay, very interesting. Okay, the carbon to which oxygen are attached, we connect these carbons via double bond to satisfy their valency after removal of oxygen. They can see very easily we got the chemical formula of the reactant. It says the question says structural formula of alkene. This is the structural formula either. If it undergoes ozonolysis, what we do exactly? Break this bond, attach oxygen both side, again you will get the same product. Okay, so that is how. If the nomenclature is there, so we can do the naming. How we can do the naming? You start naming from here. 1, okay, 2, 3, 4, 5, 6 is there. So this is going to be, we have 1, 2, 3 and it is 4 and it is 5 and it is 6 is there. Okay, so 4 ethyl and this is hex and 3 ene is there. If you like this video, please share and subscribe to the channel.